to talk about. We last lecture did allegation alternative method. We're certainly going to continue to do that. However, with the allegation alternative method, what we've done so far is when we have a high strength and a low strength and want something in the middle. What happens if you have a high strength, a low strength, a low strength, and want something in the middle? You see what I'm saying? What happens when you have more than just two ingredients to mix? You do allegations in a very similar manner, but what we're going to learn how to do is for allegations when you have more than just two components, okay? And the answer is this. You still do them in pairs. Every time you do an allegation, you have two ingredients. You have a high strength and a low strength, and something that you want is in the middle. But you can do multiples of those. You're going to do pairs of pairs, if you will. We're going to do groupings of multiple allegations that all fit that same criteria. Okay? But the allegations themselves are essentially the same. So it is pretty straightforward. So let's just show you how to do it. It says, this question says, a solvent for the extraction of a vegetable drug is 70% alcohol. In what proportion can 95%, 60%, and 50% alcohol be mixed together to make that desired concentration? So we have three ingredients, 95, 60, and 50. Mix those three ingredients so that we get a 70%. And again, I'm not calculating for volumes in this question, I'm just setting up the proportions. So I'm essentially doing just the first part of the allegation. All right? So this is really useful. If I ever give you a question that's got three or more ingredients to do in an allegation, step one is to clearly write your target concentration, because it's easy to get confused with so many different numbers. What is our target? What are we trying to make? 70%. Then list out the available concentrations. List out your ingredients, but put them in a rank order. And I suggest going from high to low. So the three ingredients we have are 95, 60, and 50. So I know my target, okay, and I know my three ingredients. The reason I say to do this, because then what you have to do is draw this over and see where your target is in relation to your ingredients. Because all of your allegation pairs have to have one strength that's higher and one strength that's lower. So you need to know where the ingredients are relative to your target. So would you agree the only one that I have higher than my target is which strength? 95%. But I have two ingredients that are less than the target, which is the 60 and the 50, are less than my target of 70%. Now I can set up my pairs, all right? Because my pairs have to have one that's higher and one that's lower than the target, and I need to use up all of my ingredients at some point. It's okay to use an ingredient more than once, but by the time I'm done picking pairs, I need to make sure I've used every ingredient once in a pair that always has a strength higher and a strength lower. So what I chose to do was to mix this one here as the higher and this one here as the lower. Does that seem okay? So then what I can do is, again, for my next pair, I only have one strength that's higher, but I do have a second strength that's lower. So that's the pair that I'm going to mix there. So I have 95 and 60 and 95 and 50. Is each of my three ingredients used at least once? And does each of my pair have one strength higher and one strength lower than the target? That's the only trick to this. You set that up first, then you do those allegations, and they're pretty straightforward. So let's do the first allegation for my first pair was the 95 and the 60. So remember, we put the high strength up on top, and then we put the low strength down below it, and to the middle and to the right, we put our target. So we have 95 on top, 60 on the bottom, and 70 to the right. Follow the diagonal arrows down, starting with the 95 down diagonally, cross subtract. 95 minus 70 is 25. Set that 25 directly across from the 60, okay? Do the same thing starting at the 60, going diagonally up. Take 70 minus 60, that's 10. Put 10 then diagonally up to the right, directly across from the 95. That answer would be 10. And remember, we drop the units when we cross subtract, because what we're measuring, what the number means, is parts. So again, and this is where I remember it's important that the 95 goes with the 10, so those connect together. And essentially here, the 60 goes with the 25. Okay? Now you notice I didn't add it up. And all of the other questions, and a lot of ones we'll do, will then kind of add up the total number of parts. But don't yet. Why? Because do we have another allegation to do still? So all I've done so far is found the parts of the 95 to go with the parts of the 60%, all right, for that allegation. Next step is to do the same darn thing with your other allegation pair. So remember, the other pair was 95 and 50. So it works the same way, 95 on top, 50 on the bottom, 70% in the middle to the right. Cross subtract, starting with the 95, 95 minus 70 is 25. Now though, going with the 50 diagonally up to the 70, 70 minus 50 is 20, so that 20 gets written directly across from the 95. And so what we have now, I'll remind you, is again, in this lower allegation, we have this 95 matching that 20, okay? And we have our new 50% matching that 25, okay? Any questions about doing that part of the allegation? Now, we haven't messed with volumes or anything else yet. We've determined the relative amount of parts. These many parts of this plus this many parts of that. Okay, we've just turned it all into parts. And that's really the end of this question to one extent. All you need to do, though, is add up and to summarize. So in the end, would you agree that we needed 10 parts of the 95 from the one allegation, but we also need 20 parts from the second allegation. So the total number of parts of 95 is going to be the sum of the both. We had to use that ingredient for both allegations, so we add up all of the parts for that ingredient. So for 95, we have the 10 plus the 20, meaning we need a total of 30 parts of the 95. How many times do we use the 60%? Just once in one of the allegations. So the total parts for it was 25. How often did we use the 50%? Just once, and its total parts were 25. So and therefore, if we add up all of the parts from the 95 and the 60 and the 50, you take 30 plus 25 plus 25, that gives us a total of 80 parts. So this essentially is our recipe right here of how to make this. Now, but even I'm not the most observant guy in the world, could we simplify that a little bit? Aren't all of those numbers kind of divisible by 5? So we're not changing anything, but I would just say the best answer to this question, the easiest answer would be simply to take those same parts. 30 divided by 5 is 6. 25 divided by 5 is 5. So again, and 80 divided by 5 is 16. So all I did was simplify that same recipe. And the final answer to this question is, I need 6 parts of 95% mixed with 5 parts of 60 and 5 parts of 50%. Regardless of which overall volumes I end up using, as long as my ingredients are mixed in those proportions, what is my final percent in the end? 70%. Okay? Let's prove that, because there was that whole allegation medial method, right? So let's just prove that those parts and actually create a 70% solution. So remember, when we do the allegation medial, step 1 is just add up the total number of parts, regardless of where it's from. So remember, we had 6 plus 5 plus 5, so our total number of parts was 16. That was step number 1. We just added up the parts. What's new about the medial method is let's determine how much alcohol is going to be in that. So to do that, we take the individual parts for each concentration times its concentration. So we have 6 parts of the 95%. So 6 times 95 is 570. Remember, our units don't cancel, but it doesn't matter. That would give us parts percent. 5 parts times 60%. 5 times 60 is 300. Those 300 parts percent. And the 5 parts of our 50% gives us 5 times 50 gives us 250 parts percent. So regardless of which ingredient it came from, we can add all of those parts percent up. So the total amount of alcohol, combining both the number of parts plus its concentration, you add 570 plus 300 plus 250, the total ends up being to the 1120 parts percent. So 1,120 parts percent you get by adding all of that up. Okay, that's the total amount of alcohol. So if we put that in the numerator, so that's the amount of alcohol out of the total number of parts. So what's 1,120 parts percent divided by 16 parts? Parts cancel, and we end up with percent, and you do that math, and you get 70. So it proves that if we use those concentrations of alcohol in those relative amounts in terms of parts, we get a 70% solution. All right? Let's do another question, one more question on these multiple ones, and we'll go all the way through. We won't just stop on the proportions, we'll actually calculate the weights of each ingredient. All right? So in this question it says, how many grams of each product must be used when mixing a 20% with a 15%, with a 5%, with a 3%? 4 different concentrations of these zinc oxide ointments. Mix all of those 4 together. So in the end we get a total weight of 5,000 grams, but that weight has a total concentration of 10%. So we want a 10% after mixing a 20, a 15, a 5, and a 3. Okay? Sound familiar? We got multiple strengths of ingredients that we want to mix together to make a unique concentration. So this is we're going to use an allegation method, an allegation alternative, using multiple strengths. So let's start. What did I say? The first thing when you have more than 2 ingredients is to clearly list your concentration target. We want 10%. Don't forget that. We're mixing these together to get 10%. All right? Then rank order your ingredients. The 4 ingredients I have are a 20, a 15, a 5, and a 3. Those are the 4 strengths of the 4 ingredients that I have. Now, take your target concentration and find where it falls in relation to your ingredients. All right? So I have now, in this example, would you agree, 2 strengths that are higher than my target. I have both a 20 and a 15. And I have 2 strengths that are lower than my target. I have a 5 and a 3. So how many pairs do you think I'm going to need to use up all 4 of those? Just 2. Okay, I can use 1 high with 1 low, 1 high with 1 low. So what I chose to do is, you can see, I chose to use in my first pair, I chose 20% from here and 3% from here. Would you agree both of those are one's concentration higher and one is lower? What do I have left? Remember, I have to use all my ingredients, but here, now my second allegation, I can use that 15 and I can use that 5. Okay? Is one strength higher and one strength lower than the target? And have I now used all 4 of my ingredients? Perfect. Could you have done 20 and 5 and 15 and 3? Absolutely. You could have combined those in any combination, so long as what? One concentration is higher and one concentration is lower. And so that you do use up each ingredient in at least one of the allegations. So again, you could have alternated those, but you need to have one higher and one lower. And I have used in my pairs, if you look here, I've used all 4 and I've always got one higher and one lower than the target. Okay? So I've picked my 2 pairs. Okay with that? Not seeing smiles, but this is calculation. I guess I won't expect to. All right, never mind. All right, so let's just do the allegations, man. We've got our pairs. We said the first pair was 20 and 3. So again, I'm going to go through these kind of quickly, right? We've done these now. It's the same setup. 20 over 3, 10 in the middle. Cross subtract. 20 minus 10 is 10. That's across from the 3%. Take 10 minus 3. That's 7. That 7 goes diagonally up across from the 20%. So I need 7 parts of 20%, and I need 10 parts of the 3%. Okay? So far, so good. Let's do the second allegation. We said the 2 combinations were the 15 and the 5. So 15 is the high percent, 5 is the low, our target is 10. Cross subtract, so again, 15 minus 10 is 5, and that goes across from the 5%. 10 minus 5 is 5, and that goes across from the 15%. All right? So let's just summarize all that. What I have is I have 4 unique ingredients, so I know I need 7 parts of the 20%. 5 parts of the 15, 5 parts of the 5, and 10 parts of the 3. Okay? You see where all that comes from? I just want to make sure you realize all I'm doing is, okay, that's summarized from that. Here's this one down here. That one goes up here. This one comes over here. And then let's add all those up. Plus, 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 plus. What does all that equal? 27. So 7 plus 5 plus 10 gives you 27 total parts. So far, so good. We've proportioned out, based off of our concentrations, we have proportioned out how many relative parts of each ingredient we would need, such that if we mix those in that proportion, we get 10% in the end. All right? Before we calculate the weights, let's confirm it with the allegation medial method. Second time. Easy breezy. Step 1 is just the total number of parts. Remember, we've already added all those up, so if you add up all the individual parts, you got 27. Just kind of did that. Let's now figure out the weight of zinc oxide, though. So to do that, we got to take the individual parts times their concentration. So we said 7 parts of 20%, so 7 times 20 is 140. 5 parts of the 15, 5 times 15 is 75. 5 parts of the 5% gives you 25. And then the 10 parts of the 3%, 10 times 3 is 30. And those are all parts percent. We okay with that? I just basically said we just determined how much zinc oxide would be in there by using those number of parts times their concentration. You add all of those up, and the total is 270 parts percent. Okay? Total zinc oxide. So let's take the total zinc oxide divided by the total weight, which we said was 27 parts. So 270 parts percent divided by 27 parts gives you 10%. So that's just showing us that those parts, when combined in that proportions, will give us a final concentration of 10%. Now, let's do what we didn't do before. Let's actually go ahead and determine the weights of each of our ingredients, because I'll remind you, what are we trying to make? Yes, we want 10%, but we want 5,000 grams of 10%. Okay? So while I have a recipe that proportions each of these ingredients out, we haven't factored in the total we want to make. So how do we do this? You can do this multiple ways. I'm going to show you one way to do it. Hopefully it makes sense to you, but if you like it another way, do it another way. Let's start with the first ingredient, 20%. All right, we said, coming from before, that our 20% ingredient needed 7 parts. All right, we also said that the total is 27 parts. So for my 20% ingredient, I need 7 parts out of a total of 27 parts. You okay with the 7 and the 27? Okay, let's set that equal to, set a proportion, because here's the deal. We know what the total amount is. The total weight we want is 5,000 grams. So the 27 parts represents the 5,000 grams. 27 is the total number of parts. The total weight I want to make is 5,000 grams, so 27 parts is equal to 5,000 grams. So I can set 7 over 27 equal to some x over the total, which is 5,000 grams. Now if I solve for x, I'm solving for the weight equivalent to 7 parts. So by doing that, I solve for 1,296 grams. That's the weight of my 20%. Okay? Is that okay? Guess what? We're going to do the same exact thing for every other concentration. So I'll kind of go just set those up here. The 15%, you look over here on the recipe, it said we wanted 5 parts for the 15%. So I take my 5 parts, and again, my total is still the same. And again, and my total weight is still going to always be the same. So I just set up that same proportion, solve it. That value is 926. Same thing for the 5%, because it was also 5 parts, so I have the same weight. And lastly, for the 3%. So you can see how I set all those up, came up with each of those individual weights. So the last step is simply just to summarize that. So based off of our weights, you can see we need 1,296 grams of 20%, plus 926 grams of the 15, plus 926 grams of the 5%, plus the 1,852. You add all those values up, what's the total going to be? 5,000 grams. And by the time you add all that up and look at the concentrations, the final concentration would be 10%. Okay? Any questions on that? So we can keep reinforcing those same skills with other examples. Now let's go back, because to be honest with you, those are good to know how to do. It's just a variation on the alligation medial method. But you got to be good at the alligation medial, because most of the time you'll still only have 2 different concentrations that you're having to mix together. So let's practice some more on those. And I like some of these questions, so let's do this one. It says, pharmacist has already compounded 30 grams of an ointment that contains 0.5% mupirocin. Okay? However, the patient now needs 1%. So we have a cream that's not concentrated enough. It's only 0.5%. We now need it to be 1%. What could we do? Well, let's add some drug to it. I do not have pure mupirocin, though. What I have is a 2% ointment. So can I add a certain amount of 2% ointment to a 0.5% ointment and get something in the middle? And what do I want? What's my target in the middle? 1%. So that's what I'm trying to do. I want to make 1% out of my 0.5 and my 2%, okay? So let's do an alligation. We said my high strength is the 2%, and my low strength is the 0.5%. Those are the 2 that I have. So let's set those up to the right and to the middle. We're going to have our target, which is 1%. Cross subtract, so 2% minus 1% is 1, and that goes down below here. So let's just make sure that we realize my 0.5 strength is equivalent to 1 part. Okay. Up on top for the 2%, again, if I take 1% minus 0.5 diagonally, that's 0.5. So again, my 2% strength represents having 0.5 parts. And what is 0.5 plus 1? 1.5, right? So this 1.5 total, it represents the 1%. So the 1%, the target that I want, needs to have a total of 1.5 parts. Okay. So far, same sort of thing. The only trick now is where do I go from here? Because I need a weight. I actually need a weight. What is the only other thing that I know is that I have, let me use the right color here, that I have 30 grams of 0.5%. Does that make sense? We have 30 grams of the 0.5. So remember that weight, what is 0.5? Which target? That weight is the same as that 1 part. So let's set up a proportion and say that down below there, that my 1 part of the 0.5% over the 1.5 total would be equal to the 30 grams I'm going to be using. I know I'm going to use 30 grams of 0.5%. That's what I had to start with. So that's the amount I start. That's equivalent to 1 part. I can then solve for the total amount, which is 1.5 parts. So solve for that proportion. So essentially 30 times 1.5 is equal to 45 grams. All right? So that's the total. Well, what did I want to know? I didn't want to know the total mixture. I wanted to know how much of the 2% to add. So yes, you could just subtract those, but bear with me. I want to make sure you can visualize. This 45 that we just solved for represents that number of parts. Well, that's the same number of parts as that, all right? So now what I can do is I can go back up to my 2% and say that I need 0.5 of the 2% out of 1.5 total. I now know the total, so I can set that equal to x over the 45 and solve for x, and that would be the weight of the 2% mupirocin. So you solve for that, you get 15 grams, okay? But does it also make sense that if I have a total of 45, and I'm using 30 grams from my 0.5%, that 45 minus 30 equals 15. The remainder of that weight would come from that. So that intuition is great, but I want to make sure you can still match your essentially weights with what they represent in the proportions so that you can use those proportions to find your answers. Okay? Okay, I love this question. This is kind of cool. So here's the thing I didn't tell you about that. Turns out that 30 grams of mupirocin that had 0.5% mupirocin in it, it also had some beta-methasone in there. I didn't tell you about that. It turns out it had a concentration, the 30 grams before we mixed anything, had a concentration of 0.025% beta-methasone. Okay? But now I've squished in my extra 15 grams of my 2% mupirocin and squished it all together. Did I add any extra beta-methasone? No, but did I change the concentration of the beta-methasone afterwards? By adding this other non-beta-methasone including ointment, I have changed its concentration. So the question is, what is the final concentration of beta-methasone now that I've mixed it all together? I know my final concentration of mupirocin is what? 1%. That's what we formulated it for. What will the beta-methasone concentration? So this is not an allegation. Do you see why I'm saying that? Are we increasing the mass of the beta-methasone? No. Are we changing the mass of the beta-methasone? No. We are changing its concentration. All right? So this is a dilution. So how did we talk about solving dilutions? Dilutions are solved using the CQ equals CQ. Remember, the mass before is equal to the mass after. It's simply the concentration that's changing. So let's set that up. C1 is the concentration we had to begin with. It was 0.025%. That comes from the question. Do we know how much of that cream we started with, or that ointment we started with? Yes, we had 30 grams of it. We had 30 grams of an ointment that had 0.025%. So I got my C1 and my Q1. So my mass 1 is 0.025 times 30 grams, all right? But what is the C2? I don't know. That's what I'm solving for. I don't know what the concentration is after I mixed everything together. So X equals C2%. Do I know my final quantity, though? Didn't we just solve that previously? What did we say when we add that extra mupirocin? The total weight was going to be 45 grams. So I know my Q2 will be 45 grams. So I know my mass 2 is X% times 45 grams. So I can just set M1 equal to M2 since I know the mass didn't change. So let's do a quick check here. Make sure I got a percent here and a percent here. I got grams here and a grams here. So my units are the same. So let's just do the math. What is 0.025 times 30? It's 0.75. What is X times 45? 45X. All you got to do then is divide both sides by 45, and numerically you get an answer of 0.017. And remember, X equals what? X equals the percent, so it's 0.017%, and that's the concentration of the beta-methasone after you've combined the two mupirocin ointments. Did you see that that was a dilution? Did you know how to handle it? Can you see why this is not an allegation? An allegation is when you're adding two mass-containing products to get a new mass, somewhere in the middle. Okay? Dilution is when mass doesn't change, but concentration changes. So that's why we use the different approach on that question. Okay? Well, let's keep going. Let's do an androgel question. It says androgel contains 1% weight per weight testosterone in this carbomer gel formulation. Okay? And you apply it to the skin basically once every 24 hours. So this is kind of like a pre-question. This is a warm-up question. It says, according to the package insert, approximately 10% of the applied testosterone dose is actually absorbed. So even though you rub it on there, that doesn't mean it all gets sucked into the skin. Only about 10% of the testosterone in the gel actually gets absorbed into the blood, okay, over a 24-hour period. So the question is if a packet is applied that contains 5 grams of gel, how many milligrams of testosterone are actually absorbed into the system? Okay? So nothing to do with altering product strength or anything else. We'll get there, but like a little bit of a warm-up question. Because there's a lot of information. Again, it's a 1% gel and 10% absorbed, and it's got 5 grams and blah, blah, blah. Where do you start? You want to know how much testosterone is absorbed. Wouldn't you agree it depends on how much you start with? How much gel am I starting with? My source of testosterone comes from the gel, so let's start with that. I am starting with 5 grams of gel. So that's where let's start this question with, all right? I apply 5 grams of gel to the skin. How much testosterone is in that gel? Well, let's start with that. It's a 1% weight per weight, meaning 1 gram of testosterone for every 100 grams of gel. If I multiply it that way against my 5 grams of gel, do you see where grams of gel cancel? And just multiplying 5 times 1 over 100 gives me now grams of testosterone. So now I know how much testosterone was in the gel. Does it all get absorbed? No. So how much is absorbed? 10%. So that means 10 grams of testosterone is absorbed for every 100 grams applied. Only 10% of what you apply gets absorbed. So I multiply my grams applied by 10 grams absorbed over 100 grams applied, and I basically then just get grams of testosterone absorbed. That's my answer, except I wanted milligrams, so the last step is to convert grams to milligrams by multiplying by 1,000 milligrams per gram. And you do that, and then you do the math from left to right, you get 5 milligrams of testosterone actually gets absorbed from your 5 grams of this 10% ointment, or gel, I should say. Okay? All right, that was the easy one. Let's keep going. Let's get back to our allegations, man, because it says how much testosterone should be added to 30 grams of this gel to increase its strength from, where did we say we started with? What are we starting at? 1%. And we want to increase it. We want to fortify it and make it stronger so that it's 1.5%. So we need to add drug. We need to add mass. Our source is pure testosterone. We have pure testosterone drug powder. We can add to this gel to go from 1% up to 1.5%, all right? So, and again, this is one you could answer either way, but since we're trying to make sure you can kind of, I still think, do this easier allegation method. Most of you will be more successful. So let's do it with an allegation. The only trick with that is, what is the strength of pure testosterone powder? What is its concentration? 100%. It is pure drug. So the high strength that we're adding with this testosterone is 100% testosterone. So let's put 100% on top, and our original gel that we're adding it to is 1%, so that's low down on the bottom. And what we want in the middle on the right is 1.5%. Do our allegation. Let's cross subtract. Starting with 100 minus 1.5, working our way down, we get 98.5. Okay? Starting down below at the 1%, cross subtract with the 1.5% and you get 0.5. So I'll remind you, we've come up with parts. So of the 100% of the pure testosterone, we need 0.5 parts. Okay? Of the 1% gel that we're starting with, we need 98.5 parts. Okay? What is the sum of those two? What is 0.5 plus 98.5? 99. So of the 1.5 total, I need 99 parts. All right? We have set up our proportions. Good. How do we go from there? What do we know? What we know is that we have 30 grams of the gel to start with. Okay, so we're starting with 30 grams of the gel. Well, which one of those parts represents the gel that we're starting with? The 1%, right? It's a 1% gel, so that represents that parts. So let's go ahead and set that equal to, because I can set that equal to the fact that I know I'm starting with 30 grams of the 98.5 parts, right? Those are the number of parts that represents the 1%. I'm starting with 30 grams of that, so let's set that over x. And when we solve for x, x really represents the weight of the total, remember? Because 99 parts represents the total final concentration of 1.5%. So what is 30 times 99 divided by 98.5? You do that math, and you see that the total weight would be 30.15 grams. Okay? That's the total weight that has what concentration? 1.5%. But that still doesn't tell me how much testosterone to add. And again, can anyone tell me right now how much testosterone do we need to add? 0.15, right? So just subtract the two. We've got 30 grams of the gel and 30.15 total. The difference obviously is testosterone, but bear with me on this. I want to make sure you realize this is the total, right? So, oh, I wanted blue. This is the total. That represents that 99. That's the same 99 as that. So I can set that equal to X over 30.15. And now X on top is solving for the weight of the testosterone. So if you set up that proportion and do that math, it turns out that X is equal to 0.15. And that's how much testosterone to actually add to the 30 grams of gel to get a total concentration of 1.5%. All right? All right, let's do this question. It's Neoral oral solution. And Neoral is a generic, or I'm sorry, Neoral is the brand name for cyclosporin, a very common used anti-rejection drug, immunosuppressant for people that have essentially a transplant, so it's an anti-transplant rejection. So here's the drug. It comes already in a concentration of 100 grams. Well, Larry, read their own slide. It's 100, I'm trying to look at it, 100 milligrams per mil, sorry. There's the concentration. So that's what we have to begin with, all right? So that's the solution we have, but what we want is to make 30 mils of a solution that only contains 10% cyclosporin, okay? So how many mils of this solution do we use and mix with the diluent to get a 10% solution, all right? The problem we have here is our units. I'm given a concentration of that in 100 milligrams per mil, but I want a final concentration of 10%. So let's start by converting 100 milligrams per mil to an equivalent percent. And you can do this lots of different ways, all right? But a percent is per 100, right? So instead of knowing the milligrams per mil, I want to know the grams per 100 mils. So let's, since a percent is 100, all right, percent means 100, let's start with 100 mils and figure out how many grams would be in 100 mils at that same concentration. So 100 milliliters times that concentration, cancel, so milliliters cancel, and I'm in milligrams. Then let's, again, multiply it by 1 gram over 1,000 milligrams, or essentially divide by 1,000, so that I end up with grams. So if you do that math across, that means there would be, at that same concentration, there would be 10 grams in 100 milliliters. Okay? Well, wait a minute. What is 10 grams in 100 mils? What concentration is that? That's 10%, right? Isn't that the definition of 10% weight per volume? Would be 10 grams per 100 mils? Don't we already have that? It was a trick question, so we don't have to do anything. We just, that is the concentration of the solution is 10%. If that's what we want, then just pour it out of the bottle. Why do you guys have to make this so difficult? All right, no one's with me. All right, so anyways, that was kind of a trick question. I will tell you, because I did look at the test already too for quiz 2, so you got to be able to do that, because in all of our C's times Q's, remember there have been a lot of times where we have to take one of our concentrations and match it to another one. And oftentimes it's milligrams or some other milligrams per mil or something like that, and you got to convert it to a percent to match that, okay? So just be able to do this calculation. If I give you any concentration in milligrams per mil, something like that, be able to convert it to the same percent, the same concentration expressed as a percent. All right? There you go. You don't look like you're happy being tricked. All right, so and here's the deal. Can anyone tell me where that bottle came from? Which country? Anyone notice? Cyclosporin is spelled with an I in England instead of a Y here, in case you were curious on that. No one cares. All right, let's go. Last question. I promise. You're getting close to being out of here. I appreciate you even coming to class. All right, so this is a kind of a cool question. I like this one. There's 2 parts to it here, and it's a good test on your abilities here. It says, a pharmacist wants to compound 4 fluid ounces of a shampoo. The target concentration of this shampoo is we want this special unique shampoo to have 1.6% weight per volume of this crude coal tar. And coal tar is a very common used topical product. It's an anti-seberitic. It gets rid of the flaky skins on top, so it's a common ingredient, this coal tar. It's nasty stuff, though. Anyways, we want 1.6% of this weight per volume in our shampoo. All right? Easy enough. Well, what are the 2 ingredients? Well, we've got 2 different things to make this. We have this Tartan shampoo that has 5% coal tar solution volume per volume. That's different, so just be aware of that. So it's got coal tar at 5% volume per volume and some salicylic acid. And we're going to mix that with some XZT shampoo that has 10% volume per volume of the coal tar solution with a different concentration of salicylic acid. And I guess the question here, if you look at the question, what is driving our combination? Is it to get the right amount of coal tar or to get the right amount of salicylic acid? It's coal tar. Remember, our target, what we are wanting to make, is something that has 1.6% weight per weight of crude coal tar. So we need to mix these in the right proportions so that we get the right concentration of the coal tar. All right? The salicylic acid is just kind of a secondary ingredient. We'll talk about it later. But that's mix them in the way that we get the right amount. So what do we need to do? Well, the first thing is let's get rid of those fluid ounce things. That's just making my life difficult. I hate fluid ounces. I need milliliters. So the first thing I would do is convert my 4 fluid ounces into the volume I actually want to make. So hopefully you remember that there are 30 milliliters per fluid ounce. So if I have 4 fluid ounces times 30 milliliters per fluid ounce, then fluid ounces cancel and we end up in milliliters. So what I really want to make is 120 milliliters. Easy enough so far? Now let's deal with the big problem. The big problem simply is going back is to this. The fact that we've got 1.6 weight per volume and yet my ingredients are expressed in volume per volume. That's not going to work. All right? So we need to convert one to the other. I would argue the only way we can address this, though, this is what we absolutely need to know, though. Keep in mind, we were given some additional information so I can deal with this. I'm told that a 10% volume per volume coal tar solution is equivalent to a 2% weight per volume of just the crude coal tar. That's a very important conversion factor. So with that information, I could convert from the weight per volume to the volume per volume. I could go one way or the other. Since both of my ingredients are in volume per volume, let's convert my target. So what I want to do is convert my target of 1.6 weight per volume. Let's convert that over to a volume per volume so I can then use my concentrations to set up for my target. All right? So all I did was set this proportion up. So what's really important is, could you have done this right here? Could you have taken that factoid and set up a proportion? Because I said that a 10% volume per volume was the same as a 2% weight per volume. So all I did was set up 2% weight per volume is therefore over 10% volume per volume. That's straight from there. Set that equal to what my target is, a 1.6% weight per volume over X. If I solve for X now, my X will be my percent volume per volume. That is the proportion, the same proportion as the 2 to 10 that I was given. All right? So if you solve for X, you take 1.6 times 10 divided by 2, you get 8, and that would be percent volume per volume. So this is the same as my target. Are you guys okay that that is the same? That is the same value. 1.6% weight per volume is the same as essentially 8% volume per volume, given that I was told this conversion. I used this conversion to set up that proportion. Okay? Is everyone okay? So now it seems kind of easy, right? Because don't I have 2 ingredients? I have one ingredient, the X sub T, that's got 10%. I've got another ingredient, tartan, that's got 5%. And what is my target now in volume per volume? 8%. This is an allegation. Let's just solve this using our allegation skills, all right? So we said my high strength ingredient had 10%. My low strength has 5%, and in the middle to the right is what we just determined was my 8%. Remember, this is what I said I wanted, so that's why that's down here, okay? Let's cross subtract. 10 minus 8 going down to the lower right is 2, and 8 minus 5 going up to the right is 3. So let me try to go back to my little color scheme here. So of the 10%, I have 3 parts. All right. Of the 5%, I have 2 parts. And of the total in the end, when I'm all done, that's going to be 8%. That's where the 5 parts come from. Okay. Same kind of setup we've done before. What's nice now is, what else do I know? What am I trying to make in the end? 120 mils total shampoo. So the 120 mils total of my 8% target would represent which of those parts? The 5. So all I have to do is take my 120 that I calculated from here, bring it down to here, and it goes up to here, and it goes over to here. So I can set that equal to X over 120 for both of my ingredients. So 3 over 5 equals X over 120. Solving for that, for my X sub T, I need 72 milliliters. Going down below, I need 2 parts out of 5 parts total. Set that equal to X of the tartan over 120 total. Solve for X, and I get 48 mils. So what is 72 plus 48? 120. That's the total volume. I've now divided that 120 mils into the amount I need of the X sub T, which is 72 mils, combined with the 48 mils of the tartan. If I mix those two together, what's my final concentration in volume per volume of my coal tar solution? 8%. That's how I get 8% coal tar solution, by mixing them in those proportions. Any questions on that? That's a colored mess. I apologize, but there you have it. Okay. Now, let's go on, because the last question is simply this. What happens to the salicylic acid? So yes, you do need those proportions and those volumes to get the right amount of coal tar. But dude, what will the final concentration of the salicylic acid be? Because we're starting with 2% in the tartan, and we're starting with 4% in the X sub T. Will mass be changing when we combine those two? Is there salicylic acid in both ingredients? Yes, so won't the mass be increasing to some extent when you put them together? All right, so the mass of one plus the mass of the other makes some new mass 3. Does that sound familiar? So instead of doing an allegation for this, we just simply need to take the mass of the first ingredient, add the mass of the second ingredient to know what we get in the very end. So let's do our C's and Q's, and so we can know what our masses are. Our first ingredient simply was the tartan shampoo, and we know it had 2% salicylic acid. So make sure you understand where this stuff is coming from. And I'll try to do my colors here again. So for the first ingredient, the 2% for the salicylic acid comes from there. And I'll remind you on the previous slide, go back, we just said that of that, we're going to use 48 milliliters. Remember, we know that quantity because that's the quantity that gives me the right concentration of coal tar. So I know that volume, that amount for the tartan was going to be 48 milliliters. So I got a C and I got a Q. So my mass is 2% times 48 mils. Well, let's go down to the X sub T. So the X sub T had 4% salicylic acid, so that's the C2 for that one. And we just solved in the previous question that we need to add 72 milliliters of that ingredient to get my total coal tar solution. So I've got its quantity. So again, C times Q would be 4% times 72 mils. The last thing is, what do I get in the end? When I'm all done, I'll get a C and a Q. Do I know what the final concentration of my salicylic acid will be? No, that's what I'm solving for, so I set that equal to X. So my C3, concentration 3, is X. I don't know what it is, but here's the deal. Will you know what the final quantity when the two things get added up together are? 120 mils. So I know my M3 is going to be my X% times 120 mils. So the only trick to this is to set it all up and bring that mass down to here, that mass over to here, and again, add those two together to get this final mass. Let's do a quick check though. Make sure percent, milliliters, milliliters, milliliters. Okay, so the units are all the same, so I can just do the math. What is 2 times 48? It's 96. What is 4 times 72? 288. What is X times 120? 120X. So 96 plus 288 is 384. You take 384 divided by the 120, and that's a new number of 3.2. And remember, X was equal to the percent concentration of the final solution, so 3.2% would be the final concentration of the salicylic acid. So great, just summarize, I know you guys went out of here. We make sure we realize we covered how to do though these allegations with more than 2 ingredients, so make sure you can do 3 and 4 and do those in pairs. And the biggest thing I would remind you on this is know which kind of questions would lead you to do an allegation. Know which kind of questions are more of a dilution or ones where you would use the CQ plus CQ type of idea. Make sure you, in the all of chapter 15 is really getting those techniques down and knowing when to apply them. So thanks for your time, guys. I will see you on Thursday ready with your homework and ready to do a review for all of these chapters.